In today's experiment, we're going to be looking at a colligative property of a solution. And in order to do that, we're going to use something called a conductivity probe. Before I use the conductivity probe, I have to make sure it's calibrated. Once it's hooked up to the LabQuest, I'll click on the unit bar where we see the units of conductivity. I will then press the calibrate button and a 1-point calibration. Make sure that the conductivity probe has been thoroughly rinsed and dried, and then place it inside of the calibration solution and set the calibration to 1000 microsiemens per centimeter. Microsiemens are units of conductivity. Then I will use the wash bottle to rinse off the conductivity probe into a waste beaker. Be sure to thoroughly rinse the probe between each batch of measurements. Then, fix the probe inside of a 3-finger clamp. Make sure that the probe will be below the 70 milliliter line, and add 70 milliliters of deionized water into the beaker. The first step in our experiment is to determine the conductivity of pure water as a background. Once my conductivity probe is in place, I'll turn on the stirring and take a measurement of the conductivity of pure water. Once I have the background conductivity, I'll begin adding in 1 drop of a 1 molar sodium chloride solution. And record the resulting conductivity. I'll repeat this process, adding a total of 8 drops of a 1 molar sodium chloride solution, allowing about 5 seconds or so for the solution to equilibrate. You should see that the conductivity doesn't change until you add another drop. I will add a total of 8 drops of my sodium chloride solution. Then I will turn off the stir plate, deconstruct the setup, and pour my beaker's contents down the drain. I will then resume the setup and repeat the experiment, adding 8 drops of calcium chloride and aluminum chloride in separate experiments that you'll see in the rest of the video. All of the waste today, once it's collected in the waste beaker, can be poured down the drain with excess water.